So let's look at a sorting algorithm as coded up with a microbit. I'll gloss over any elements that are very similar to yesterday's problem where we found the minimum of a list of numbers. So this should already look familiar. All we're saying is we're going to set the problem up so we have this list of 10 numbers. The minimum, you may remember, was 10. And we're also going to set that little empty box in which you can shunt numbers by making a conditional check. We're going to set that to 99999. So what does the actual algorithm look like? Again, parts of this should be familiar from yesterday. Yesterday we had for element number of list, or for number in list, we're going to go through each of the numbers in the list. And if the number is less than the previous number you placed in the box, or to start off 99999, we're going to change the box to the number. And after you'd been through the entire list, we found that what was left in the box in this algorithm was the minimum. So that should be familiar. New aspects here are that you have to do this 10 times. You can think about this as finding the minimum first time through, and then, which we'll get to, you're going to discard that minimum and try and find the next minimum, the second lowest number. Then you can discard that minimum and find the next minimum, the third lowest number. So you have to go through 10 times because you're going to find 10 numbers being the minimum each time each of these repeats through the list. You may have chosen to write this yourself as for element number of list, or for number in list, and then again for number in list, and then again for number in list. But I asked you if there might be a more compact way of writing this, and this is the more compact way of doing it. 10 times through, each time through you do your little minimization, finding the smallest number algorithm. So we're going to go through 10 times. You may have spotted that, or you may have written for number in list 10 times, then that's fine too. Another new element to the algorithm you have to think about is you have to set up this other list, new list, and you've got to add the value that comes out of your little minimization, smallest number algorithm, to that new list on each repeat. So you're going to go through 10 times and you're going to build up in the new list the minimum value each time. Up here where we set new list to empty array, that is just saying to the microbit, we're going to have a list with nothing in it so that we can add something to it each time through and build up this list by adding values to the end or appending them. Another element I hope you may have included is realizing that you don't just add the value to the end of the list, you have to also, the new list, you have to also remove it from the previous list. So in the slide I showed you for the sorting algorithm, I have an arrow here that is taking the 10 from the list and is putting it in the new list. Well, that means you have to remove it from the list. If you don't remove it from the list, then each new time through the list where you're trying to find the minimum, you'll just encounter 10 again every time. And so your new list will get built up as 10, 10, 10, 10, 10, 10, 10. You have to actually remove it from the list, make it vanish. So next time through, you don't find 10, your minimum algorithm finder will find 22 instead, which you move also to the new list. So you need some aspect in your algorithm. It doesn't matter how you wrote it, but the way the microbit writes it is list, remove value at list where the list is equal to box. So first time through, find where it's equal to 10, remove that, as well as appending it to the new list. So that's that whole arrow pointing up here. We've actually removed the number rather than leaving it in list, as well as putting it in new list. Another element you may have missed, which is very important for this algorithm, is as you're going through, every single time you need to repeat this line from how we initialize things, the set box to 99999. You have to do this again. You have to set the box to a big number. Why is that? Well, think about your original work. First time through, we set box equal to number, the minimum, which was 10. And so box is equal to 10 as we come to the bottom here of this repeat. And if box is equal to 10, and we go back through with box equal to 10, you're never going to find a number in the list which is less than 10, because 10 is the smallest number. And so you have to set box back to the large value each time you do this for element number of list or for number in list. That's very easy to miss, and it shows you how writing good algorithms, it can be a very sneaky process, because if you forgot this step, you would just build up a list of tens in your new list instead of the new minimum each time. So again, to recap, you have to go through 10 times your algorithm for finding the minimum. You have to not just add the minimum to the new list, you have to remove it from the old list, and you have to remember to set your box back to a very large value so that on your second time through your if number for number in list loop, you're going to compare to this large number, not compare to the 10 that you found the first time through the loop. So if you remembered all of those elements, well done. That's very difficult to do if the algorithm you wrote down included them. But if the algorithm that you wrote down included any of these new elements, then that's really good work as well. Finally, I've written a little extra here. You don't need to worry about this. This is just so that I can loop through the numbers in the new list and I can print out the numbers to screen. And we're going to do this when we press button B. So let's see if our algorithm works. Button A is the algorithm, button B is just displaying it, and here to remind you is the list of numbers. So let's start the microbit. Let's hit button A. That ran our algorithm. And so if this has gone correctly, everything should be sorted when we hit button B to display it. 10, 18, 22, 31. You can see that it is indeed displaying the numbers in order. So this algorithm we've written down, you wrote down and we've coded up, is indeed a sorting algorithm. To illustrate one of my other points, let's see what would happen if we forgot this aspect of the algorithm. We forget to set the box back to a very large number so that it's still the minimum we found last time when we loop through. Let's start things again, run the algorithm, and see what the result is. It's 10, 10, 10, because we don't compare to a very large number the second time through, the second for number in list. We compare again to the number we found the first time through, the minimum, the 10, and so we're never ever going to find a smaller number than 10, and so at the end, new list just consists of tens. So that's why this, which I think is the hardest thing to remember in the algorithm, and I'm sure many of you didn't even conceive of it and missed it completely, is the hardest thing to remember. We put it back in, and this time, when we print to screen, we do indeed sort the numbers.